All right, so we've actually seen a lot of these problems when we did forces, so it's good to kind of refresh. So it says two forces, F1 and F2, are applied to a box on a frictionless horizontal surface as shown below. So if you look at that diagram, you know you have a frictionless surface. It literally tells you in the question, it also tells you on the diagram. You know you have a block. You have F2, which is the second force, going to the right, which is 2 newtons, and you have F1 going to the left, which is 12 newtons, okay? The question then says, if the magnitude of the block's acceleration is 2 meters per second squared, what is the mass of the block? Okay, this is like a two-step question right here. It's not so direct. Okay, so they're saying the magnitude. Okay, magnitude just means a number. Okay, so keep that in mind. So they're saying the magnitude of the block's acceleration is 2 meters per second squared. Okay. And then they're saying, hey, what's the mass of the block? Okay, so that's the thing we're looking for, mass. So remember that anything, think of the number line, anything that goes to the right is positive, anything that goes to the left is in fact negative. All right, so we can't just jump the gun here and go use our net force formula yet. Okay, we have to do something first. So the first step that you're going to want to take, right, you're going to want to find the resultant force, right, that net force, okay? So if you recall, I said that the net force, and this is the one that's not on your reference table, is called sigma F, which means the sum of all forces, okay? So whatever is acting on that object, that is what you are going to write down. We do not need to worry about the normal force of the gravity force. They're not relevant to us. We know that for pretty much all objects, they are going to be equal to each other. So that's not a big deal for us to take into consideration. But we do want to take into consideration these horizontal forces, okay? So if I did F net equals, it doesn't really matter. You could put 2 newtons plus or minus 12 newtons, whatever you want to do. You could also do minus 12 newtons plus 2 newtons. Really doesn't matter the order. So if you're wondering why I put this minus sign here, well, keep in mind that this vector right here is pointing to the left, and that is a negative direction. Okay, so we have to take into account be negative. So that means that my net force is now equal to negative 10 newtons. Okay? Now we can go to our reference table, right? Still on page 6 under mechanics, and we'd find the following formula. A equals F net over M. You're probably wondering, how did I even know how to get that? Well, if I list out my givens, I have an F net that's equal to negative 10 newtons. I have an acceleration that is 2 meters per second squared. My unknown here is the mass of the object. So this right here is my equation, makes the most sense. Now I'm just going to substitute. So my acceleration is 2 meters per second squared. My net force is negative 10 newtons over M. Again, you want to put this over 1 to make it a ratio, right? Because then we can see that we can cross multiply. So we have the following. 2M equals negative 10 divided by 2, divide by 2. M. So here, we have to take a really important observation. You cannot have a negative mass. There's no such thing as a negative mass. So what you have to do is you actually have to drop that minus sign. I know it kind of seems a little weird, but you are going to drop it from your calculations because that's actually incorrect. Obviously, you can drop it at the end. That's fine as long as you know that the mass can never be negative. But just kind of keep it consistent. So we know that 10 divided by 2 is 5 kilograms. Again, we are working with a mass, and mass has the unit of kilograms, and that is choice 2.